Hello students! We will move on today to volumes of three-dimensional figures. Just a quick reminder, we have classified the three-dimensional figures into three big groups: prisms, pyramids, and spheres. And we have also two special ones because this figure here, for instance, is a cylinder. Cylinder is not prism because there is a curved surface. All the faces of prisms are always flat. And cylinder obviously is then not prism, but it's the closest family because it has very similar features. And for pyramids, under pyramids we put here cones. Cones is certainly not pyramids because also there is a curved surface, but it's like the closest in features. Today we are going to look at how to find volumes of prisms and cylinders. And in textbooks, sometimes the formulas are written differently, so don't get confused. Sometimes you see area of base times height, and base is a little bit of a misleading word because what is so important here, before you find volumes of a prism, you always have to identify which one is the cross section. So the cross section is the figure, two-dimensional figure, that when you cut the prism along this figure, you will always get congruent shapes. So it's always the same shape and the same size. So this is called cross section, and it is a better word than calling it base, because then in this case, for instance, you might think that the base is the rectangle on the ground here at the bottom, although it is the base, but it is not the cross section of the prism. Because if you cut the prism along this rectangle, the more you go up, the smaller the rectangle is. So therefore it's not congruent, it's not the same size, therefore it is not the cross section. So very easily, once you figure out the area of the cross section, you will multiply it by the height. And height sometimes is also called length of the prism. And do not get confused, it's just how you perceive it. If you have the cross section at the bottom, so for instance the cylinder here, the cross section is at the bottom, then obviously you can call the distance between the bottom at the top, between end to end of the cross section, you can call it height. However, since we know that this prism has this triangle as the cross section, then we probably will not call it height, we will call it length, but basically it's just the distance between the very end to end, the very first and the very last cross section of the prism. So here you have the one in front and the one at the back. So the distance between those two, we will call the length of the prism. And if it is vertical, we will call it height of the prism. So don't get confused, it's basically just the same thing. Okay, so to find the volume of this triangular prism, we are first going to find the area of the cross section. And since it is a right angle triangle, we can safely take this side as the base and the height of the triangle because they make 90 degrees angle. So 12 times 16 divided by 2, we have 96, and the unit is centimeter squared. To find the volume, very easily, we multiply this area of the cross section by the length of the prism, which is 9 in this case, and then you will have 864, and the unit is, be careful, centimeter cubed. It's a unit for volume. Okay, now next one. Now we will try to find the volume of the cylinder, and it's very similar to prism. The formula is just area of the cross section, which means the circle here. This is the cross section of the cylinder, obviously, because when you cut it along the circle, you always get the same shape and the same size. So area of the cross section obviously will be area of the circle. So pi times radius, which is 21 squared. And you will have, if you put it in your calculator, you will have 1385.5 44236 and so on and so on. And to find the volume, we will just multiply that number by the height of the cylinder, which is 30 in this case. And if you put it in your calculator, you should get 41,563.2708 and so on and so on. So we can safely round it to the nearest whole number, 41,563, and the unit is centimeter cube. In the next video, we will look at a bit more complicated shapes. So for now, we'll stop here and good luck with the exercises.